Okay, thank you. So I think even Anna was it who mentioned it today in the keynote that with security reliability, we're often thinking not only about employees or something. So especially in the context of CI/CD, we are thinking, okay, that's an internal system, right? That's only we are using that, but it's not just the employees that are running things there. You might not be aware of it, but if you look at the headlines that we are seeing there, there's people out there that are especially trying to sneak out things. It doesn't matter if it's your production system or your CI/CD system, which might even have more powerful permissions. So just a quick overview of what we are doing now. We will start with a quick look at the evolution of software delivery systems so that we're all on the same page a little bit on what we are talking about. Then we'll go through a few potential problems, solution examples to that, and also some mitigation strategies. So it will be a bit of super detailed and a bit of higher level overview all together. So when you're thinking about how we're getting software into production, how did it work in the very beginning? Okay, few of you maybe think back several years, you had your, I don't know, PHP free file, you wanted to get it running on your server, you changed code, you put it with your FTP client on some site. That was quick and easy, right? It was only you and you putting it up there. But soon you probably was annoyed by like .1 new, this is the real file or something, so you worked with something like a version control system. But still, you checked in your code, but you uploaded all the stuff still directly to maybe one target machine. So, well, then you maybe notice, okay, I have no idea what am I running on my target system and what is on my notebook. So the workflow changed a little bit. Got to put it into your version control system, do something that put it into the target system. So we'll talk about the something black magic thing a little bit later. And maybe if you're at the company, it grew, more people. So you had more projects working on that, you had more target systems, but your things worked pretty well to put it into production, so you just reused that. So it grew and grew over time. And maybe your company even did even better. So it wasn't only your team working on it, but a whole set of teams, a lot of developers with a lot of repos, with a lot of target systems. So if we recap that quickly, we could say over time, to deliver software, the workflow got way more complicated. It isn't as easy as it was maybe. More and more components got involved into it, and the components often were shared because it didn't make sense to reinvent the wheel all the time. So you had the systems became very central often to deploy things, especially if you had an organization split like between dev and ops. Maybe there was one centralized system that one team offered to another to bring things into production. And of course, the user base often grows, company get bigger and so on. So we talked about this black magic, or we didn't, this black magic part. I mean, obviously it's not. So if we're having a look at these things, what is typically happening in a CI/CD pipeline, we're having some code, whatever that might be. Then we have sort of a build phase. It might be either compiling or you're bundling or packaging things together. And then you have some artifact coming out of this phase that you have to bring somehow into production, which usually you could say is in a deploy phase. So for some people, that's maybe one tool, one script that's doing all of these things. For bigger systems, it might be separate systems that are concerned about these topics. So we can already see it's like a bit like several lanes that we are having here. And several interactions happening. So also at first, we are having a user management. Maybe if you're using GitHub or GitLab, whatever, it doesn't matter. You have a user management there. Who can commit to the repo? What are the rules to that? Then you maybe have some CI/CD system. Maybe it's a Jenkins or something like that. This has its own user and permission management. If it's a separate tool, let's say Spinnaker or something like that, it will have a separate user management. You have own permissions there, and so on. And also, in the end, you're going to deploy your artifact to some place. So it might be an AWS account, it might be your target fleet in your data center, doesn't matter. But most likely this thing also has some user and permission management. So not only is there a lot of permission management involved, also we're handing over things between those components. There's various places. So either we are having like a webhook reaching out to the build system, or we are polling it, fetching things from there. They need to authenticate each other. Same is between those steps. We're handing over a build artifact to the deploy pipeline, and with the deploy pipeline, we are trying to put something somewhere else. It's also some sort of a handover. So there's a lot of places in play where things are happening. So what if we could use these many places to confuse them, to do something that they shouldn't be doing? So we've seen these many components, and all of them having a lot of power itself. So they are doing things on our behalf. So we could try, if we have access to only one of them in the chain, to trick them into doing something that they shouldn't be doing. Because they have the permissions, but just regulate it down sort of with their own permission management system. So if you're recapping it, we had this whole pipeline we just saw at a very central point in most cases. So if we're going there, we might be able to gain access to even more systems. So what could we do actually to trick it into doing something that we don't want to maybe? So that's more than like maybe some internal person doing something. So if you have a big CI/CD system that has access to all of those repos, we could just tell a build job that's working with some permissions, why not just fetch another repo? And execute that code with that permissions the original job was intended to do so. Nothing stops us from doing that. If we only have permissions on the build system, we don't need permissions anywhere else. That's enough. Or the same works the other way around. So if we have only access to one repo in our build system, that's safe. But the system has access to all the target roles, target servers, and so on. It might be easy to just get from there and tell it use another role by having because we have permissions in there. We don't have any permissions in any other systems. So we could get more privileges than we should have in the end with something like that. Also, but we are not going into that today, if build systems share components, you might even be able to escape these build systems. I'm thinking about a shared Docker socket or things like that, and get credentials from another build job. So maybe let's summarize a few of the problems we could think of and then have a look on what can we do about that. So we have the big central systems that have a huge blast radius. So it's not only a security, but also operational issue. The systems are acting on behalf of someone else. So it's someone that's triggering the code, but they're acting with their own role identity permissions very often and doing things on behalf. And with that, we are effectively masking who actually initiated the change that led to all this pipeline runs and this deployment. We don't know. We only see it was the CI/CD system. So in some cases, the CI/CD system might be even allowed to push back to the Git repos. We're talking about that also. And in the end, if we are thinking about the whole pipeline, it means if we can push to Git, we have access to prod somehow. We can run code in there. That's just the thing. And also one thing where we can't get away from, we need credentials in there somehow. We are executing things that is exactly the place to put it into prod. So we need some permissions to do it. So we need to find a way how to handle those credentials. We can't say we just don't put them in there. That doesn't work. Also, the components don't identify each other. Whole topic for another talk. Artifacts are also not signed. So we don't even know during the handover if they changed maybe. We have no idea. And one very often overlooked point is we are building maybe code that we are not aware of that we are building. So not generally saying that open source and so on is bad, but we might be building forks of a project from people we never heard of in our own infrastructure. So let's have a look at all these topics. Maybe the biggest one is this acting on behalf. We have the system, it has some permission, and it does it with its own identity, and just because we're telling it not to do something bad, it shouldn't be doing anything bad. Yeah, and nobody sees anymore who did what. So it's really hard to trace things back down. If something got wrong, when did it happen, and who initiated it maybe. So we're remembering we had these many places where we have the user permission and permission management of the systems. But what can we do about this? So as far as I know, it's not possible to attach credentials to some, maybe a commit or something like that. If it is and it works, tell me. Would be interested in that. Otherwise, we could maybe make sure that all the systems don't have a separate user management. They're having one thing or going back at least to one thing. And if it's not really needed for at least the credentials and so on that we need to deploy to prod, why have a user management at all in between? Why not trying to remove it? If it's not there, we can't get it wrong. And with that, reduce the options on where we could elevate our privileges, where could we confuse things. So I want to show you an example of something that we've built at Scout24. I'm sorry for the huge graphic, it's a lot of components involved. I tried my best to explain it. If something is super weird to you about it, please raise your hand so I can go into it a bit more. It uses some common components that maybe many of you also use. It's GitHub, it's Jenkins, it's AWS, and many of you maybe can relate. So it's a bit AWS specific. I'm just curious how many people are in here that are working on AWS to get a feeling. Okay, it's a lot. Okay. I'm going to the components always if you're getting there, so don't worry, I'll explain them. So we are starting down here. That's the typical thing. We want to do some change, and we want to bring it to the production. So what is happening? There a git push you're doing. So in our case, this is going to the GitHub. GitHub is sending out a webhook to our Jenkins infrastructure. In our case, this means Jenkins checks, okay, should I build this thing? Yeah, maybe. And starts an agent. So we don't have any static agents. We spin up on an ECS cluster a container per build step even. So we are creating an agent for exactly that job now. Okay. So we are not only creating the agent, but also we are populating some additional metadata to this agent. So what's in this trusted metadata store is, for example, something like who did the commit, who did the push, and also, of course, which repo, and so on. And this is put there a little sort of out of band, so it can't be changed by any build job. So that's why it's sort of the trusted metadata store. They can't be overridden by anything. So our build job, let's assume we've built something, we want to upload it to S3, just some file. We need some basic credentials to do that, to upload to the S3 bucket. So maybe you're using just AWS CLI, AWS CLI S3 copy. So we need AWS credentials to do the next step. So how do we do that nobody else could sneak in there? So if you're deep into AWS, you might know that the SDKs or CLI tools requesting some metadata endpoint to get credentials of an EC2 instance or a container, for example. This metadata endpoint lives at this exact IP address there, and it's a static HTTP endpoint. You can even use curl to use that. So what we are doing is we are intercepting the call going there. We are not letting that go directly there, but technically it's an IP tables rules that enforces it, that this traffic always goes to a sidecar container, which is the so-called cross-account proxy. This is a piece of software that just takes the requests coming in there and does some further checks, and only then does hand out the credentials. So advantage of that is it's totally transparent to any tools that are being used. No change needed. Okay, so what does this cross-account proxy thingy do? It's checking this trusted metadata store to get the information like who committed, who pushed, which repo, and so on. So we have now the information who pushed. Let's say it was me. It was this WebRats guy, which is also the GitHub name. So we have no idea who is WebRats anyway. Nobody knows, especially not the company. So we need some mapping to map this to a real person. So in our case, GitHub is synced with Azure ID. So we have a mapping table which says, okay, this GitHub user is this person in our Active Directory. So, okay, now we know this is an ID identity. So we can go to the ID and check, okay, what groups am I a member of? So it fetches the list of all the groups I'm a member of, so that's how we do overall permission management, and maybe many of you do too. Then there comes a component into play that might not all of you have. It's a service, but it boils down to a big JSON file that says which which group has access to which AWS account and which AWS role in that account. So it's just this mapping. So it's behind a service, but technically it's really a JSON file on GitHub. So we know the groups that I have, and with that we know to which AWS accounts I have access to. So let's take the next step, because a role isn't yet the set of things I am allowed to do. So the cross-account proxy calls out to that account and says, okay, what's the policies for that role, and fetches them. So we now are in a state that we know what exact policy is mapped to this GitHub person that did the push. So we have now some kind of information collected and can use that to call out to an AWS service to get temporary credentials, the STS security token service. Maybe not well known, doesn't have a user interface. So it's basically doing an assume role call, but we are adding a lot of additional things here. So the first thing, or the most interesting thing, is the session policy. So this is sort of a permission boundary you can add to an assume role, which means no matter what role I'm getting, how many permissions this role is having, I can't go beyond the permissions that are defined in the session policy. So even if the role allows admin access, but the session policy only allows for S3 upload, I can only do S3 upload. I can do nothing else, although the target role gives me way more permissions. So with that, I have no way to ever go beyond the permission that were granted to me as a person. Another thing that we're adding here is the so-called external ID. It's also an AWS-specific thing. I'm pretty sure it exists in other services too. It's just a string that we can add to this assume role, and this string can be checked in the target role in the account. So in the policy, you would be writing like only if, I think it contains, if external ID equals the string, then allow the assume role. You can write this in your IAM policies. So in our case, we would be setting the name of the repository. So what does that help us? That the owner of the role that created it in the target account can say, I'm only allowing this specific repo. So no other repo could be assuming, or no job with another repo could be assuming that role. And we care also about tracing. Remember we said we don't know, it's still using another role, not mine. So we are adding a session name, it's called, with the user ID. That's something that will show up in your CloudTrail logs. So you will see that this session was assumed by me as a user because we're adding that. That's sadly not in the graphic. So it's called session name. With that, we have all the traces that we need. We can tie it back to a real user. And then, after all these steps happened, we're returning those temporary credentials to the tool. There's a bit of challenges involved because you have exactly 1 second to do this, because that's the timeout of the SDKs typically. So there's some caching and so on involved. Okay, so that was a lot of talk for just this thing. Maybe let's recap just what's the good thing, what's the bad things about it. Good thing, okay, we have only one identity used. It's mine. We're checking the permissions out of band. We are not trusting the systems in between. We are using only this one single source. And we are not trusting the CI/CD system and so on. It's a third party that's encapsulated. The user can't gain any additional rights that they don't have at all in any account. It's transparent to existing tools. No change is needed there. The target role can ensure that only specific repos use itself and not the CI/CD system as a whole. And the credential lifetime can be very short because all those AWS SDKs are renewing automatically. So we could go down to like about 10 minutes or so. And we're adding the session name so we can trace things back to a user if we would really have to. Well, we reduced user management. That's cool, but there's still things where we could confuse things. As you've seen, the complexity increases quite a lot with that. And also, this external ID check is something that the creator of the role needs to do. We can't do it for them. So if they don't do the check, it's not being checked. Then the whole CI/CD system could access it. So that's a little bit of a gap in the solution. And a thing that maybe is a trouble for many of you, I guess, is that you need to somehow have a mapping then in the end of the Git user to permissions in an AWS account. That's sort of the biggest prerequisite you have to be able to do that. And there's some specifics to it, so there might be some things that may not work on Azure or GCP. I'm not into that detail level on those platforms. But if any one of you tries that out on another platform, let me know on Twitter. I would be really interested if that also works elsewhere. Okay, so what else? We talked about the blast radius before. We have this one huge big system that has probably access to all the targets. And also, if it breaks, everyone is affected. And what's the worst thing during an outage? You cannot even deploy and fix the problem. So maybe we can do something about that. So we're seeing if the CI/CD system is affected, all the target systems might be affected. But also, we remember if we allow going back to Git from our CI/CD pipelines, also all of our repos might be in the other way affected because we could commit back maybe if we're not scoping credentials. Talking about that in a minute. So what's the solution to that? Well, it's the solution that we always use if the blast radius is huge. Make it smaller. So don't have one huge CI system, have many, many small of them that are separated. So what we did at Scout24, so we had until last year or so, we had two big build systems. We had one for AutoScout, we had one for ImmoScout, and they were huge. What we're having now is we're having over 100 small CI/CD systems. Many of you might think, okay, that's horrible, 100. So, but they are all exactly the same. So they are all created the same way, maintained the same way. So it's technically one template that's managed also by us as a team. So it's not all the teams operating them on their own, but they're all separated and sliced currently at a team slicing. So if one of the permissions fail, if one of the systems fail, it's not good, but it's not that bad because it only affects a small part of the company. Okay, so we remember the exposed credential thing from the very beginning. So it's not only bad actors, but it could be something as simple as setting in your bash +x, -x, always mix it up, and everything's echoed. So your environment variables may be ending up in the log, everyone can read the logs in the company, all your credentials are there. That's something that happens every day, all the time. It's just so easy to happen. So nobody had bad intentions, still happened. Either they're sent to a malicious third party with some of the things we've seen before, that there's really bad actors, or maybe somebody is like, oh well, I don't have access to that system, but I need it now for developing. I can get it out of the CI system. Maybe I'm just sketching it there, and then I can use it for development on my notebook. Also happens. No bad intentions, but well. So what can we do about that? That's basically also what Anna said before in her talk. Limit the scope. So give only out the permissions that you really need to that build job. Don't have just one role. If you have multiple things that you need to do, make it multiple roles, make it only doing that, what it should be doing. I know it's way easier to just write an S3 star or whatever in your IAM policies and only have one, I know, but you shouldn't. So sadly, there's not great tooling around that would tell you about things that are not in use of API calls, but that could be one way. If you're deep into AWS, you could find it out via CloudTrail logs if things are not in use, but another story. The other thing is rotate often. And people often ask, okay, what is often? To me, everything that's longer than an hour is not often. Maybe a day, depending on the credentials, but try to rotate it every hour. Because imagine, if someone got the credentials, we have the thing that's sending them out to some third party. Maybe they're not fully automated, you're stealing your credentials, then you might be lucky within an hour, but it might already be way too long. If it's a day, someone even manually could look through their logs and like, oh, that's nice credentials, I'm trying them out manually. So an hour even could be a very, very long time for valid credentials. Okay, so I'm curious, how many people of you do have pipelines that need to push back to Git or SVN or something? Oh, it's nice. That's not that many. But I don't want to blame all the others, because sometimes it's difficult to just get around it. So maybe back to why it's maybe not a good idea. Often you maybe don't have scoped credentials. You have your one CI/CD user for all of your organization, right? And then you're adding it to your repos, and people adding it to more and more repos, and they can push maybe to, if you did your permissions okay-ish, then maybe they can only push to the repos you wanted them to push, but most likely they can read at least all of your repos. And if you were not so savvy about your permissions, maybe they can write to all repositories, which, if we are thinking back, could be a great way to gap the security measures we implemented before, because we're saying we're only running for one repo. Okay, cool. But if another repo can push into that, well, then you're still in. So a typical use case I showed here, it's the dreaded Maven release bumping the version thing. So there's a solution to many of these things, but often they're not as comfortable as before. So for this example, you might be able to store the version number in Git tags that you push from your developer machine and don't have the rest of that into it. That might be a solution, but of course the saying don't do it is maybe making it too easy. But if you have to, think about it. What could happen? So make sure that the credentials that you're using are really scoped to that repository, so you can't push to any other one. And maybe they are even that if it's pushed by a non-human person, you might not want to run the follow-up a pipeline on this. Because very often it's also not needed. For the version bump in Maven, you don't need to run the full pipeline on it. It's just that it's stored now. So either say, okay, it's by the initiating user that initiated the first run, but that's difficult to say. So if you can't be sure, then better say, okay, I'm not running on pushes done by people I can't identify or map to a person. Okay, so almost done. We remember we had this, we talked about it. We are pushing, if we can push to Git, then we can have access to everywhere, or at least what this thing is supposed to do. So I know many people are like, don't have the perfect permission management on maybe GitHub, GitLab, or elsewhere. You just add a team, and then they're adding other people, and so on, it adds up. So really keep in mind that the first place of your security now for your production system is your Git repo now, because it's all connected. So maybe bump the priority of making your permission management of Git a little bit up, because all the other things are nice if you fix them, but it doesn't help if people can push everywhere. So we can change it, so we have to deal with it. So there's a screenshot of what you maybe could configure if you're using GitHub to make that not happening. Or so you could be also, for example, depending on your use case, make sure, okay, only things go to production master, and to master only after at least 1 or 2 reviews can be committed. That's one easy thing you can do today, for example. Also, be careful if you're building, doesn't matter so much, mostly open source projects. If you're building an open source project on your own infrastructure, that's cool, that's nice. Maybe you're helping them out. That's great. But if you allow forks from everywhere, also cool. But if you allow builds of those forks, someone could fork your code, change everything in the repo, and to create a pull request back to your repo, and then your build pipeline would start running immediately. With code you've never seen, you don't know anything about that, and it's running in your infrastructure. It's cool if you do that in a separate infrastructure, but think about running forks or pull requests from forks in your own infrastructure can be a way for someone to easily get into your infrastructure. So maybe just don't run them, or don't give them any credentials. Run them in a separated space, so they maybe can still run the tests or some linting or whatever, but they can't get access into your systems. So that's pretty much it. Sadly, we are not there yet. So that was a lot of things we talked about today, but we didn't even touch on like third-party dependencies, pinning, all the NPM stories you heard. We didn't talk about those. So there's more to do, but it's a good start to get started with those things. So also remember, no matter how big the change is that you're doing, you're getting to a place with better security. So don't let you stop from seeing, oh, that's huge what they built. That's way too much effort for our organization. Start with one part of it, start with something small and get there over time. Also, if you're curious about how we're doing things at Scout, so my manager, Janet, gave a talk on how we're handling GitHub integration at the GitHub Satellite. So there's a YouTube video up of this. And also we talked about how our CI/CD system looks like. So my former colleague Philip did a talk. There's only the slides online, sadly. It's not completely up to date, but the basic structure didn't change that much. So if you're curious about how we do CI/CD building at Scout, have a look there. Okay, that's it. Thank you.
Thank you, Andreas. Questions for him? Okay, until the first person decides, I do have a first question. You mentioned hourly rotation of credentials. I actually think that's very good, because if you do it so often, you don't forget how to do it, and hopefully you have built automation around it. And it's not like that panic moment where our credentials leaked and we need to change them now. Do you have automation built around that? And please tell me yes. And sorry, but repeat the question.
Yeah. Okay. So the question is, if you are creating or rotating them so often, have you built automation to that, and maybe how does it look? So yes, obviously that's the good thing. If you're rotating so often, you have to. There's no way of not automating it. To be honest, it's not everything that we have for 1 hour. We have also a few things for 1 day. We very often, so we're living pretty much in an AWS world. So it's typically a bunch of lambdas and SSM parameter store that we use to renew or get new credentials from a sort of a privileged set of credentials, and then store the short time ones in a shared store that is accessible by the CI/CD systems. So it's not any black magic. There's also AWS Secrets Manager, I think, that can do that, but usually a Lambda is good enough also to do this.
We have the first question here.
So I think this was pretty much about security. So how do you secure your accounts which you use to access it?
Okay, so the question is, how do we secure the accounts? How do we access Git? So we are using GitHub, as I said, the cloud version. So we have integrated it with SAML. So if you log in, you have to go through the SAML web auth page. Also, you have to the tokens that you have at GitHub. You also need to go once through the SAML process. Also, additionally, because GitHub is a special case, you don't have corporate accounts, but you link the public GitHub accounts to the corporate ones. We also enforce the 2FA of GitHub for all people. And user management is synced to Azure AD, so if people are either changing to another part of the organization or leaving the company, they're getting kicked out of the GitHub repos.
Question here.
So did you consider using the instance principles instead, so that the tokens are additionally scoped to the ephemeral box you're bringing up for your build or deploy part of the process?
Yeah. So the question is, did we consider the instance or ephemeral credentials that are provided by AWS already?
Yeah, the ones that are specific to the instance.
Yeah. So yeah, but we did. The problem that we saw there is that it's a little bit too. So it's more implementation details. So we're running this all on ECS clusters and so on. So the problem is there that we couldn't add our additional checks on top of it that we wanted to have. Mm-hmm. And as far as I know, there's no way to hook additional checks into the AWS credential generation directly. And also, we sort of had this cross-account proxy, as it's called in our case already, because of the specific setup we had where the CI/CD tooling is running at different accounts from where it's deployed. And then it was, we needed a way to add this external ID in the very beginning, which we couldn't otherwise.
Another question here.
Okay, I assume Jenkins is an isolated environment. It's private resource in AWS. And I want to ask how you handle the webhooks from GitHub to Jenkins.
Okay, so the question is, Jenkins is running in some isolated environment. How do we handle the webhooks coming from GitHub? Well, we are in that sense, maybe we're a bit brave. We are sort of following, I think Google had a paper on that, don't have intranet. The things are actually reachable from public with strong authentication in front of it. So we're allowing for the webhooks, for example, GitHub has a defined IP range. We can discuss IP ranges is maybe a bad security measure, but so we're allowing them also them to get to this specific endpoint and send the webhooks there.
There's the concept of zero trust, where you consider everything untrusted and only take decisions based on particular elements. So like our internal network at Google is untrusted by default, and similar to the internet. It's basically how the internet was kind of created to, or meant to be. It's not a castle with walls and firewalls. It's open, and all of us need to prove that we can access something. One last question? Okay, two last questions, but that's all.
Did you consider using WAD by any chance for credential management as well as instead of your proxy, because it could probably
So it didn't get the first part. Did we consider? No, we didn't. So because we had this cross-account proxy in place and we are pretty much living in the fully AWS world, it wasn't sort of a consideration there.
Last question?
So in the acting on behalf
Yeah.
section, you mentioned that there's no way to attach a role to a Git commit. Would a GPG signed commit help, or would it make any sense to like build or accept only signed commits?
But the signed commit, if I understand it right, only tells me who did it. It doesn't give me the power to do something with that signed commit that has already permissions. So I'm not passing along credentials that I could use. So it would be better if we would only allow signed commits, that's true. But in that sense, we are sort of trusting, that's one of the confusion possibilities that are still there. We are trusting that GitHub is telling us the right user, because it's also a bit out of band with the webhook. So in that sense, we are trusting on GitHub that this is the correct one. So signed ones would be way better, but also not one step more to roll out in an organization with several hundred engineers to do that.
Thank you very much. I'm sorry, but we're out of time, so I'm sure that Andreas will be around to
Will we?
answer further questions. Thank you so much for attending, and a big round of applause for Andreas.